G'day guys, and welcome back to another Quick Concepts ActionScript 3 video tutorial. What we're going to be doing in this example is showing you how to move on angles. So I know math is really kind of scary sometimes, and unfortunately we do need a little bit of it when we're working with game design, especially when we want to move something realistically or semi-realistically. So what we're going to be doing here is creating a simple little tank type object, and with the arrow keys we're going to be able to rotate our tank left and right and then actually move on that angle that we're rotating in. So this is going to be the base foundation of like a little mini shoot 'em up game with a tank turret. In the next tutorial we'll probably have a turret sit on top of the tank, and it's going to track where the mouse is, and that's always going to follow where the mouse is located on the stage, and we're going to make it shoot in that direction too. But just for this one we're going to make our tank move around just using the arrow keys, and yeah, we're going to be talking a little bit about trigonometry. Not too much, but enough to at least get this little basic game happening. So to get started, I've just got my usual main class set up, so main FLA. I've got a document class tied up to main, and the stats are pretty much the same. Frames per second 60, size is 800 by 480, and I've got my document class set up and good to go in Flash Develop with main AS. So the first thing I'm going to do is head back over to Flash, and I'm going to create my little tank object. So to do this, I'm going to start off by just creating a green square, nice and simple, and then I'll create another square with a black color, just kind of pin it to the side, and I'll tap that in a second. And actually this tread looks a little bit better, so I'm going to delete that one, move that in, and just hold down Alt and drag it over to the other side. So really basic looking shape for a tank. Okay, and I'm going to highlight that and turn it into a movie clip. I'm going to call it Player Tank, and its registration point is going to be set in the center, and we are going to export this for ActionScript. We'll call the class Player Tank as well. Press OK, and that looks pretty good. So let's delete it off the stage. We've got it stored here in our library with a linkage name of Player Tank. So back over in Flash Develop, let's create a class that's going to do that for us. So I'm going to add a new class. I'll call this Player Tank, and it's going to extend sprite, because once again we're only using one frame in our timeline, so we can extend sprite instead of movie clip. Press OK, and so the first thing we're going to do is what we typically do, is check for when this object gets added to the stage. So listen for the added to stage event, and just like normal, we're going to add an event listener, added to stage, and we'll go to a custom function called onAdd. And I'm going to click on that, Control-Shift-1 in Flash Develop, and generate that event handler. Okay, so now that we've got our object on the stage, what we need to do is set up a couple of listeners so we can control its movements. So if you remember back to the game that we made in the video tutorials for the basic shoot 'em up, these controls are going to be kind of similar, or these listeners, sorry, are going to be kind of similar. So I'm just going to put a little comment in here, set up listeners. So the first two listeners we're going to add are going to be ones for the key control. So I'm going to add them to the stage, and they're going to be listening for when a key is pressed down, and we'll make it go to a function called handle key down. And the next event listener is going to be for key up when the user releases a key, and we're going to handle the key up. And then finally we need a listener to loop through so we can actually update our object on the stage, just like we did with our missiles and our enemy object. And this I'm just going to add to this class. So I'm just going to add an event listener, going to be an enter frame, and we'll make it go to a function called player loop. Cool, so that's pretty much all we need for the listeners. Let's go ahead and generate those event handlers with Control-Shift-1. Okay, so now what we need to do is we need to find out the key codes of when the user presses the up, left, or right key, and we might even put the down key in there too. So what I'm going to do first is set up a couple of private class members so we can access these variables down here and here. So basically they're going to be a Boolean type for when the key gets pressed down, we set it to true. When the key gets released, we set it to false. So I'm going to set up a private variable, and this one's going to be for our up key, and that's going to be a Boolean, and let's just, yeah, we'll do it this way actually. We'll set an up key, then we'll set a down key, which is also going to be a Boolean, a left key, another Boolean, and a right key, which will be a Boolean. You don't have to add private var in front of all your definitions if they're going to be kind of similar. In fact, you don't even really need the private var more than once. You can just concatenate it on with a comma every time, but just for keeping things nice and easy to read, sometimes it's easier just to set out all your private vars. But in this case, because they all relate to each other, that'll do. So we've got our keys set up. Now what we need to do is set up a Keyup handler that's going to check if these keys are being released. And we're going to do something a little bit different here. Instead of using if statements to test all the key codes, I'm going to use a switch statement. So it's something a little bit different from an if. In fact, it makes it a little bit easier to use when you're doing multiple if statements all at once. You can use a switch instead. So how we start that off is start off with a switch, and we're going to be switching a value that we send into it. In this case, it's going to be our event key code. And then we open it up just like we would an if statement with curly braces. Then we're going to test for all the possibilities of what our key code could equal to, of what we need to track. So in this case, we're going to start off with a case, and we're going to check if our key code is 38, which is the up arrow. So let's put a comment in here for up arrow. And we're going to set our up key to equal false. Because we're in the handle key up, that means the up key is no longer being pressed down, so we set it to false. And then we break out of that case. So that's how you set up one switch statement. It's kind of like an if e.keycode equals 38, set up key to equal false, and then end the curly brace, but we say break instead. And then we put the next case in. So case of 40, and this is going to be for our down arrow. And we're going to set our down key to equal false here. And then we break out of that case. And I'll just quickly do the left and right key. So this is going to be case 37. And that's our left key. Break out of that. And then our final case is going to be 39. And that's our right key. We'll set our right key to equal false. And break out of that. So I'll just do a quick Control-Shift-2 in Flash Develop, and that should format my code. Yep, that looks neat. Okay, so that's pretty much our handle key up function done. We're going to have something very similar in our key down function, so I'm just going to copy the whole switch statement and paste it down here in our handle key down, and tab that back in, and just set all these values to true, because when we go into this function, if we're holding down key code 38, we want to set our up key to be true, and likewise for all of these. Okay, so that's up and running. Now we need to work out our player loop. So if you remember back to when we set up our player control, we just made it move left and right. And we're going to be doing something similar to here, except we're not going to be changing its X position. We're going to be changing our player's rotation. So let's get the simplest thing working first, and that is we'll get our up key working. So if our up key is true, so it's being currently held down. We're going to set this object's Y position. We'll set it to minus equals 5 for the moment. And then we'll test for our left and right keys. So if our left key is being pressed, let's change this object's rotation to be minus equals 5. So we're going to turn to the left in degrees, 5 degrees every time our player loops updates with our left key held down. And then likewise, if our right key is being held down, let's change this dot rotation to be plus equals 5. So that looks alright. Let's give this a save and a test and see what it looks like. And of course we've got nothing here because we haven't created a new player object on the stage. So let's head back over to the main class. I'm going to create a new variable as soon as we load up a constructor. We'll call it player, and this is going to be a player tank object that we have set up here. It's going to be a new player tank, and we're going to add that child to the stage as player. And we'll do a little bit of positioning for it too. So player.x, let's position it to the center of the screen. So our stage is stage width divided by 2. And the same deal with the player. Its Y position, we'll make it half the screen height. So our stage is stage height divided by 2. So let's save this and give it a test. Okay, so we've got our player showing up on screen. If I press the up arrow, you can see our clip moves up a little bit, and if I press the left arrow, the rotation moves left, and the right arrow, our rotation moves right. So that's working pretty good, but if we're facing out this way and we press the up arrow, it's still moving up on the stage because all we're telling it to do is move up in the Y coordinate. So we have to fix that, and unfortunately we've got to fix that with a little bit of math. So let's get the basics of the rotation and movement working. So down here, what we need to do is we need to work out how much do we need to move along the X position. So use this as an example. Say our player object is facing out this way, and we want to move in a diagonal fashion like that. So between this point here and this point here, how much do we need to move along the X position and how much do we need to move along the Y position? That's what we need to work out based on the rotation that we're facing. So in order to do that, we need to use two functions that come with trigonometry and that are built into Flash called sine and cosine. So to work out the X position, I'll work out our distance to move in the X position. We need to use math.sine, and I could explain a lot more about trigonometry, but if people want a trigonometry lesson, I'll make another video tutorial on that. I just want to keep this tutorial kind of short, so just take my word for it that you have to use sine for this, for the X position, and cosine for the Y position. So I'm going to set up a variable, and it's going to be called dx, so our distance to move in our X. Let's make that lowercase actually. And that's going to be a number. And we're going to make that equal to a math.sine function. And what we need to give this sine function is an angle in radians. Now, there's two different types of rotation units. There's radians and there's degrees. Now, Flash uses degrees, but typically all math functions use radians. And radians is like a different kind of way of moving around a circle. You have 360 degrees in a normal circle, but in radians, I think it's something like 2 pi. Pi is that weird 3.14 number, and you basically have two of them in a full rotation of a circle, I think. Yeah, should be about that. So what we need to do is we need to convert our player's rotation from degrees to radians. So let's make up a little handy function which we can just use anytime we need to. So I'm going to create a private function down here, and it's going to be called degrees to radians. And all we're going to do is send it in a number, which will be called num, and we're going to return a number. So we're not going to say void up here. So what we need to do is process that angle in degrees and give back a number in radians. So we're going to return, actually let's set up a variable for this. Yeah, we'll call it radians. It's going to be a number, and the formula to figure that out is going to be our angle in degrees, which we're going to be sending in as num, and we need to multiply that by math.pi and divide that by 180. 180 is half a circle in degrees, and math.pi is half a circle in radians, so they kind of work themselves out in a ratio. So once we have that figured out, we can return our radians number. So we send in, say, 180 degrees, it works out what it needs to be in radians, and it sends it back as a number. So over here we can use our function degrees to radians, and we can pass it, or we can send in whatever our player's rotation is up to in degrees. So that'll work out our x component of what we have to move. Now to work out the y component, so work out the distance to move in the y position. We're going to set up a new variable for that called distance y, and it's going to be a number, and we'll make that equal to math.cosine degrees to radians, and we're going to send in this rotation again. Okay, so now that we've got how much we need to move in the x and how much we need to move in the y, we can just tell our player object to move based on what these two numbers are equal to. So instead of saying up key and moving our player up here, what we can do is set our player down here. Actually, I might just comment this out for the moment, just for an example. And we're going to set this player's x position to be plus equal to whatever our distance x is. And then this player's y position is going to be plus equal to whatever our distance y position is. So let's save this and give it a test. So now, oops, that would happen, wouldn't it? So what we need to do is add a speed variable, because at the moment our angle is actually facing straight up, so this is automatically going to be processing. So we need to multiply this by speed, and we don't actually have that working at the moment, and we should have added that before we did this, but we'll see how this works anyway. So just above where we set up our onAdd and we add the event listeners, I'm going to set up a couple of variables which are going to control like the basic properties of our tank. So the first thing we need is the speed, or what the speed of our tank currently is. So I'm going to set that to be a variable called nSpeed. That's going to be a number, and we'll make it start off at 0. Then next up we need an acceleration amount. So how fast do we want this tank to increase in speed when that up arrow is being held down? So I'm going to set up another variable for n acceleration. That's also going to be a number. We'll make it really small. Make it equal 0.2. And now we need a max speed. So how fast is our top speed of our tank going to be? So n max speed. And just to play around with, we'll set that to 3 pixels per frame update. And then we obviously want our tank to slow down when the up arrow is not being pressed. We don't want it to come to a complete halt straight away, because that's just not how movement works. Something slows down if you're not accelerating anymore. It doesn't come to a complete and abrupt stop. So we'll set up a new variable called nDrag, and that's how much player object's going to slow down, and we'll say it slows down 0.1 pixels every frame. And finally, we need to figure out how fast we want our tank to turn left and right. So this is going to be its rotation speed, or its turn speed. So I'll set up a new variable for that called nTurnSpeed. And we'll let that equal 2 to start off with. So 2 degrees left and right. And actually, we can leave it as 5. We tried 5 before, that worked. So all of these variables are currently created in this onAdd function, and we need them to be accessible down here as well. So I'm just going to turn all of them into a class member by pressing Ctrl-Shift-1 on them, and they get added up here to our class member definitions. Okay, so all of our private variables are set up here now, and we have them initialized down here. So when we move up, what we need to do is we need to take our current speed, so update our current speed with our acceleration. So our current speed starts off at 0. So we can say nSpeed plus equals our n acceleration. So just say this loops through 5 times for an example. Our speed starts off at 0, and then we add an acceleration amount to it. So our speed is now 0.2. On the next frame it loops through, it's going to be 0.4 for speed, then 0.6, 0.8, and then 1. And then it's going to keep incrementing up and up and up until we get to a max speed, which we'll set up and then block off or cap off at there. So this speed variable is now going to be how fast we move in any given direction, and it's always increasing when our up key is held down. So what I need to do now is in our left key, we need to move the turn speed. So instead of just saying 5, we can say our n turn speed. And likewise down here, we can change to be our n turn speed. So if we ever need to change our turn speed, we can just change it at one spot up here, and it'll update down here. So now that we've got our distance to move in our x and y, we need to actually multiply that by our speed, because at the moment this is going to move very, very slowly. It's not actually going to go anywhere or do anything. So I'm going to multiply this by n speed, and I'm going to multiply this down here, our y position, by negative n speed. Now the reason I'm doing negative n speed down here is, in a normal math coordinate system, the 0, 0 position starts down here in the bottom left corner. Now with Flash, it starts up here in the top left corner. So as we move down the stage, we're actually plussing to y, or adding on to y. And in a normal math coordinate system, we're adding to y as we move up the stage. So that's why I'm setting it to negative speed down here, because when we press our up arrow key to move forward, which you expect to move up the stage, we have to actually be minusing from it to move up the stage. Okay, so that's looking alright. Let's give this a test and see what happens. So our player's here. I'm going to press the up arrow, and you can see our player just falls straight off the screen because we have no sort of damping or no drag. And let me test that again with a turn. So you can see here I'm turning a little bit, and our player is actually following along that angle now, because we've set up that math.sine and cosine. So now let's get our tank to slow down. So I'm not actually pressing anything at the moment, apart from turning it, and it's still moving forward. So let's get that slowing or that dampening effect working. So just before we apply the speed, I'll apply our movement to our tank. Just before we do that, let's set up the drag. So what we want to happen every time this frame ticks through is we want to slowly be taking away from our end speed. So we can say our end speed, let's minus equals the drag amount from it. So say our end speed got up to 1 after 5 frames and then we let go of the mouse cursor. In the next 5 frames, what's going to happen is our end speed equals 1 and we're going to minus equals our drag amount, which is 0.1. So it'll then be equal to 0.9. On the next frame over, it'll be equal to 0.8, then 0.7, and 0.6, and it's gradually getting slower and slower. And because our speed gets slower and slower, when we multiply it by our movement in our X and our Y position, it starts moving on the screen a lot slower. But we need to cap it at a certain point, otherwise it's going to keep going into the negatives and our clip will actually start reversing after a while. So let's limit the speed. Oops, limit the speed. So we're going to say if our end speed tries to get less than 0, let's set our end speed to equal 0. So it caps off at the 0 mark. So let's save this and give it a shot. So I'm going to press the up arrow for a little bit and let go. And you can see it moves and then it slows down because we're gradually taking away from that speed. So now I'm moving and our tank can actually move pretty fast as I'm holding down the up arrow. That's getting kind of, yeah, crazy. So let's limit how fast our tank can go as well. We set that up here as our max speed. So let's set a limit in the opposite direction. So else if our end speed tries to get faster than our max speed, let's set our speed of our tank to be equal to our max speed. That way it can't get above that 3 marker. And what I'm going to do is actually slow down the turn speed. I think 5 is a bit too much. Let's set that to 3. And let's give this another shot. So I'm going to press the up arrow and turn. That looks pretty good. So yeah, there we go. Pretty much moving in angles now. So yeah, that's going to be it for this tutorial. I did want to get a bit more into the trigonometry bit, but unfortunately there's not going to be enough time for that in this video tutorial. I don't think anyone's going to have a burning desire to learn trigonometry that much, and if you do, I will make another video tutorial explaining a bit more in detail why we choose sine and cosine and how we actually get those numbers. But for now, I think this is going to be enough to at least get a little basic kind of game happening. So in the next tutorial, I'm going to be talking about shooting on angles. So now we've got the movement happening. Let's get a turret going onto the tank in the next tutorial and have it follow the mouse, and then actually get, when the mouse clicks, to actually shoot a bullet in that direction. So we've got a lot of things all happening at once. We've got movement on a tank with the arrow keys and shooting with the mouse cursor. So yeah, hope you got something out of that, guys, and I'll see you guys next time.